Hello and welcome to another sample code walkthrough for our Postgres class. We're currently working on connecting Python and Postgres. And so the first thing we're going to do is, and by the way, you can get the sample SQL that I'm using. I really prefer to run through this by simply copying and pasting. After the class, you can keep these SQL files. They're great examples. I refer back to them myself because once I figure something out, sometimes it's like put two parentheses around it. I'm like, why did I do that? But I would keep these. So this file is at www.pgfree.com/lectures/06python.sql. And I always put comments at the beginning of these files. So the first thing that I want to show you, so what I've got going here is I've got one screen that I'm going to, one tab that's going to have my copying and pasting stuff, one tab where I'm going to run my Linux, Unix commands and run all my Python code, and then one tab that's connected to my database. And you may need another tab that has your tunnel if you're behind a IP filtering. So you may need a fourth tab, but I'm just all set. So the first thing that I suggest that you do every once in a while is just do a DT command in PG for E. And you see I've got a couple of databases, DocStem and StopWords, DocStem and StopWords, and I mean I should probably clean those up. So you just say drop table, DocStem, oops, boy, I can't type, DocStem, Cascade. Yeah, something was wrong there. Okay, drop table DocStem, Cascade. Cascade just means if there's any foreign keys, it wipes out the other tables as well. StopWords. And now I'll do DT. Now don't delete either any of these py-free debug meta or result. Oh, I got to get rid of this Python fun too. Drop table Python fun cascade. Python fun cascade. So now I've got three tables left: pg-free debug, pg-free meta, pg-free result. And these are all things that the autograder is going to use and or need. So if you mess these up, there is an early assignment that gets them set back up for you. So that it's not fatal if you delete them. You just got to go back and get them fixed. Otherwise, the autograders are going to be unhappy. They're also a way for you to look at results of the autograders. But we're not doing autograder right now. I'm going to clear my screen, and so let's get to this. So the first thing is you've got to have a connector, what's called a database connector, and it's got to be a piece of code installed in your Python. And you can check to see if it's installed by just saying, going into the Python and saying import PSYCOPG2. Is that what this is? I can never remember what the name is. Psychops. That's what it seems like to me. And if that works, then you're good. Don't run this pip command. But if it doesn't work, and this is the part where it all depends on how your Python is set up, and everyone installs Python in a weird way. If you got an Anaconda or this, I actually don't even use virtual environments, and people tell me I'm terrible, but I just have, my Mac is nice and clean, and I've got a brew installed Python 3, so I can just say pip3 install psycop2. And it says PG2. Says I've already got it. So I'm good. That means that, and of course what will happen is this code will blow up in simple.py. So let me go grab the simple.py code. I just used a wget to https www.pgfree.com/code/simple.py, and that in effect downloaded that file. So I can edit that file, simple.py, and so we see that. The next file I'm told to get is a wget pgfree code hidden dist.py. Now the key thing here is if you take a look at hidden dist, in general when people build code and they're going to give you like sample code, hidden dist is copied to hidden dist.py. And so the file that really matters, the file that's really going to be used is called hidden.py. And you can move it or you can copy it, hidden dist.py. And then the idea is that hidden dist has sample data, but hidden has your real data. Now I'm not going to show you my real data. I have my real data in a folder right next door. Oops, copy hidden py dot. So I'm going to copy that. Yours won't be in /code. And so now sitting here, I've got hidden dist py and hidden py. Hidden dist has sample data, the sample connection data. That's the connection data. That's same connection data that you're using over here to connect to your database. It's all in there. I'm not going to show it to you. And if you take a look at simple.py, we're importing it. And then all of the secrets in this connection. So when you do this COPG2 connect, you've got to tell it the host you're going to, the database that you're going to, the user that you're going to connect with, and the password you're going to connect with. And that connect timeout is just 3 seconds. So what happens is this, this secrets, that's just going and grabbing the secrets, which is just a dictionary, out of that hidden.py file. And then I can look it up in that dictionary, the keys that were in that file. Now, connection in Python it's not exactly the same as, it's very similar to, in a sense, this connection. But you don't, when you type commands, you get what's called a cursor. And so if I do a /dt in this case, and I say select star from PG4E result, just for yucks. In a sense, what we would do is we have this connection, but then we would create a cursor and then use the cursor to send the command, and then the cursor would then allow us to read the records that come back. Oh, that's too long. So the cursor would take this command, select title from PG4E result, it would send it to the database, then we would get back, in a sense, a handle, and then we would loop through and read all of the records that come back in the record set. So you see this where we make the connection. Now the connection can blow up if you have the wrong ID or the wrong password or the wrong host or whatever. But really, if we want to send commands, we ask for a cursor. So we say, hey connection, give me a cursor. And a cursor is what we send SQL commands to inside of Python. So I'm just putting SQL, this drop table if exists Python fun. You'll see that I drop often when I'm writing Python code. If I really want it to start fresh, I drop the table and then I create the table, as compared to making myself manually drop or create the table. I'm going to print it out and then I'm going to execute it. So the execute, that actually sends it and sends it to the database. And that could blow up if I made a typographical error here, and we'll see a mistake in a second. It'll blow up. That execute will blow up. Then I'm going to create a table. I'm going to just get a auto increment serial and a text, and I'm going to run that one. So that's sending that. And then this con.commit, we do this on the connection object, that basically flushes it all to the database server. Sometimes the connection in the cursor, to be efficient, it doesn't actually send every command instantly. It kind of queues them up. And then, and so commit says, look, you may or may not have sent all of these commands, but I want you to send them now. I'm going to wait. So when you see this commit, what you might see is your program running and running and running, and you do a commit and it pauses for a second, and it's forcing all that stuff in the database. And the commit does not finish until data is actually written to the disk in a database, which is really quite nice. And then I'm going to do insert 10 records. The first thing that you see here is that there is a %s. This is a substitution parameter. And insert into Python fun line values %s. The %s is a substitution parameter. And if I'm going to execute that SQL, then I send it a tuple with a one-to-one correspondence that this variable txt, which is a string, is a one-to-one correspondence to these %s's. Now this little txt comma parenthesis, this is the weird thing we do in Python when we have a one tuple. We go percent thing, comma, close parenthesis, and there's only one of them, but that's the way it knows it's a tuple. And so it's just one tuple. We'll see later when we have more than one of these things, it actually makes more sense. There's the SQL with the substitution areas as the first parameter to execute, and then a tuple, which is the variables that represent the substitutions. And then I'm going to commit. So these 4 inserts might actually not be sent to the database. It might just kind of remember them. But when the commit happens, then all those 10 things are going to be there. You can do a select statement, right? So we send a select statement, right, and print it with a where clause, etc. And I do the execute. Now what happens is then at that point, this cursor, once I've executed that select ID line from Python fun where ID equals 5, then cur is like a handle, and I can read it. And the fetch one method is kind of like read one line, or read one row, as it were, because you can, in this case, I'm asking for 2 things, ID and line. And so row ends up being a tuple. Row sub 0 is ID, and row sub 1 is line. But if there was nothing, then fetch 1 will give me back none. Otherwise, I'm going to print it out here. Okay? So that is kind of a return value. That's the pattern of a return value or a return set of records. So the fetch 1, you can, and we'll do this later, we'll do it over and over and over again in a loop until row is none and that you kind of hit the end of your record set. And the whole thing is very efficient, and it might call the database once, it might send a network request once or twice, but it's all optimized, and you don't worry about it. You just say, let me read through those returned records. Then what we have is insert another insert, where we're going to insert another line with this returning ID, and that's where we want to know what was the unique key in the serial column that was assigned. And so then we just give it some more text. We're actually going to send the second line twice, last line twice, and then we're going to, this insert actually returns a record set, and we fetch that record set, and then we take the sub-0 element of it, and then that turns out to be the ID. And then you can, then the next thing this thing is going to do is make a mistake, where this is a syntax error in the SQL to show you how the cur execute actually blows up. Now this is going to die right here, so they'll never get to the point where it does the connection commit, and then cursor close, which is a good way to clean things up at the end of this program. Okay? So let's go back here, and just before we start this program, so this is one of the nice things. So when these Python programs are running, you can simultaneously watch what they're doing. This one here is going to run so fast we can't stop it in the middle. Some of your later applications are going to run slowly, and you can watch what they're doing as they're talking to the database. So the first thing we notice is there's no table here. So now we're just going to run that Python 3 simple.py. So it dropped the table, it created the table, it inserted all those rows, it selected an ID line where ID equals 5, and it found the line 5. So I can go take this one over here and I can run it. So you see that's what that select ID line from Python fun where ID equals 5 gives me back a row, row 5 that says have a nice day 4. And you can see I see that same thing. Then I insert a new record. So if I do a select star over here in my PSQL from Python fun. Ooh, I'm always transcribing my O and my R from. You can see that. Oh no! What happened? Oh, look! See this new ID 11? That's pretty awesome. See new ID 11, and then I blew up. Let me show you what happened there. Because the thing that freaked me out is I did a select star from Python fun, and I do not have a row 11 in my database. Can you guess why that is? Let me bring up to sample.py. Simple.py. Right? So I did this insert, and I printed out the new ID. But somehow, when I go look in the database, it's not there. Pause the video if you want to think about it for a minute. Just stare at it. Okay. If you didn't pause, now I'm going to show you. So this is an example where the SQL executed, but because this blew up, it never did the commit. And what happened was both the SQL for the insert statement and the SQL for the select statement were kind of running, and this ran, but it didn't actually flush it to the database until we said concommit. So this is an example where this insert sort of happened, but it didn't happen because it didn't get flushed because of the concommit. So you got to be careful where all of a sudden you're like, I'm really surprised that my data didn't end up there. Now you'll notice that what I tend to do is sometimes you have a thing called auto commit where you're going to put a commit after every one of these execute statements. That's a bit of overkill. So you'll notice in some of the things I commit every 10 inserts or every 50 inserts or something like that. Otherwise it'd be a lot slower, and you'll see when it's doing a commit, when we run some of those other bits of code, it's going to work. So there we go, a little bit of simple Python just to sort of see what the basic idea is of talking from Python to PostgreSQL.